one of the exciting and interesting things about working with the partners too was operations. And one of the lessons I learned there, which really applies more than just to partners, and applies to operations in general, is of course the space station is not just the hardware machine, but it's also the people. It's the crew, it's the ops people, it's the sustaining engineering folks, it's the management team that really make that organism work in a sense. And a space station has a lot of requirements documents, and you write down a lot of specifics about how it should behave and what the parameters are, what the tolerances are. So all that's actually kind of the easy part, or it's not easy, but the more, I would say, black and white part. But there's a lot about how a space station behaves that has to do with people's behaviors, which can be sometimes, which is very hard to say I have an absolute knowledge of how people are going to behave. So that's obvious. What I find that when you have different cultures involved, Russian, American, that Japanese, European, that it actually exacerbates that issue because the cultures can be very different, not just on how we walk around and interacts with our family, but our culture and how we have gone into space and what we're worried about, how we interact with our team can be very different. And those differences, you got to be careful because those differences can conflict sometimes at very dangerous moments, and you have to. One of the big challenges for the ops team is really to understand that and feel like they can mitigate those. In other words, you're not going to change everything about how people behave, but you understand it enough that you can mitigate any risks that you would have. So I remember one particular example when I was running the MMT, the mission management team for Space Station. And the mission management team is basically, you have a manager from the program, Space Station, and then you also have a Russian representative because they have their own program on their side. And then you have the ops team, the flight director, and you have the sustaining engineering, you have safety, and the crew, and they're part of this team. And the team basically blesses the longer term plan over the next few weeks, like what the priorities are. We're going to do payloads, we're going to do repair, we're going to do an EVA. That they kind of bless the plan, and then they resolve issues sometimes. Real-time issues are really dealt with the flight director, but if there's time, hey, we've got this thing broken, and what do we do? So we had an EVA. It was on the Russian side. This was after the Columbia accident, so there were no shuttles flying. So all the EVAs were on the Russian side at the time, and the Russians needed to go out, and I believe there was a payload they were attaching on the back end of the Russian segment. So just like today, the EVA though had both a Russian and American astronaut. So there were two people going outside. So we went through the plan. We concurred on the priority. On the Russian side, basically, we just make sure we agree to when it's going to happen and that we believe safety stuff is done. But the Russians run their EVA, right? So we bless the part that we get to vote on. We concurred with going out on it. There's a funny thing in this time frame where, if you remember, the space station is to hold its attitude, it has thrusters on the Russian segment because they're the only ones that have propulsion. But on our side, we have these control moment gyros that we can use to hold attitude, and they're much better for keeping us within the microgravity limits because when you fire a thruster, it's a big bang and everything moves. Well, these gyros are much more subtle, and so they can hold our attitude and they don't mess up our microgravity experiments. So they're great. And so in general, we try to use those. It also saves prop. But every once in a while, you have to use the thrusters to kind of reload the gyros in a sense. And if the station starts losing attitude because the gyros can't control enough of the torque, then the thrusters come in so the station doesn't start spinning. So usually when you go on an EVA, you want, especially if you're going in the back end of the Russian segment, you don't want the thrusters coming on because the crew's back there. And so the plan was we'll be under CMG control, the crew goes outside, everything will be great. But we had a problem on a previous EVA where something was happening when the Russians went outside, where there was a torque created that swamped the CMGs, and the thrusters wanted to come on when the crew's out there. So we still were trying to figure out what was happening. It turned out to be that the Russian suits were sublimating. They were actually sublimating enough gas, which was hard to believe at the time, enough water, that it was causing a thrust. And when the two of them were in a certain position, especially on the back end, the lever arm was big enough. That's what was happening, and the CMGs couldn't overcome it. So we had talked to the crew and said, okay, if this happens again, here's what you need to do. You need to let us know, first of all, if you go close to the thrusters, and we need to make sure everything's stable, because the EVA was going to have them go back there by the thrusters. So we thought we had a plan, everything was cool, and we were going to, and we thought we had mitigated this potential risk. But this is where it got interesting. The Russians also, their culture was that in the dark, when they were in the eclipse of the sun, their culture was that the medical guys on the Russian side told the crew to stop. They were supposed to rest. If you're in the dark, you should rest. And on the ground, the medical guys have full authority to tell them to do that. What we were finding was the crew was moving anyway, even though the Russian guys thought they were staying, the crew wanted to get on with the work, and so they would move even though it was nighttime. So we didn't know that. So we had told the crew the risk, but sure enough, we get into dark. The Russians guys think they're not moving because they've been told not to move, but they started moving because they're hardworking. They want to get ahead of the plan. They move. We get this thing, CMGs get swamped, the thrusters come on, and there's a crew member not in the keep-out zone, but not very far away from the keep-out zone. And so I remember looking at that going, how the hell did we get to this point? Because we thought we had an arrangement. So turned out the crew was fine. They weren't in a dangerous position, but it was a great close call to talk about. We had assumed all along that the Russians were going to follow their set plan, which include when it's dark, stop. The crew had assumed, because in the past they had done it almost every time, that when it got dark they would move anyway if they felt they could get ahead in the task. So we had no one trying to be deceptive, but we had two different senses of what was going to happen. And in this particular case, by moving when we thought they were stationary, they put themselves in a potentially dangerous situation. And so the ops team of both Russian and American got together and figured out what had happened and make sure that they were clear communication with the crew, and so that was all resolved. But at the moment, it was a close call that again we should have seen, but it was again behavior that both of us were looking at it in a different way. So you need to look for those things. Sometimes it's dramatic, like operations. Sometimes it could be more subtle, like an integrated test that you do. You have to make sure that your procedures are well defined, that you can maybe even run through a sim of, okay, how are we going to do this when these things. We have some integrated tests with ESA, big structural tests, that we're going to have to make sure they're used to running their own test. Now they're going to run it over here with us, that we have good comm, and then we don't subject the vehicle to something that we didn't expect. So you got to run through all those kind of things. Like testing and even analysis, we need to be real clear on assumptions, on input variables, like, for example, on loads and other things, and even on factors of safety, on conservatism, because we definitely come at that in different ways, and we each have our own biases about what we've experienced in the past. So it's important to penetrate that next level to make sure your integrated work, whether it's an integrated analysis or an integrated test, that there aren't hidden things, gaps, which would be worse, or you over-test. And so I think that would be a really good strategy for that.